going to do is pull this out of the cabinet and just have a look and make sure that things are okay before we try powering it up. This particular set came through, I believe, a deceased estate. It was sold on an auction site here in New Zealand. I'm very, very fond of Pacific. Anyone that knows me knows that the predominant sets in my collection are Pacific. It's part of the reason why I've chosen to do a Pacific set this time round. And partly because I have two of these. I have the console as well, and the console is incomplete. Both of the dial mechanisms are gone, and so all I have are the escutcheons and gaping holes. So it'll be really interesting to see how they're done in here. This is a potentiometer for the noise suppression control, and this one is a tuning gang because this is the tuning control. So it's going to be interesting to see the mechanisms and how they work. This particular grill I'm hoping is original, but it looks like it's just been sprayed with some silver paint rather than re-chromed, and this grill is just nasty. It's awful. I'm not sure what they were thinking there, but it's not even close to period correct. It just looks hideous to me, so that will be going. Overall, the cabinet's been refinished. I don't know what it's been refinished with. It almost looks a little bit and scratches a little bit like polyurethane. So that will probably come off. I don't know what the original finish looked like on these, and that's going to be a bit of a problem in trying to replace it. I've never seen an original one of these. This is the only one I've ever seen in the flesh. The only other one I've seen is a black and white photo. So, no idea what they're supposed to look like. The console, the one I have, is the only one I have ever seen, period. I've never even seen photos of another one, so that's also been refinished, and it also looks like it's been polyurethane, so I don't know. Well, that's rotating fully around with no stops, so whatever's in behind that is not well. I forget what the mechanism is called. It's an American company that made them. It'll come to me. But should you have spares, particularly the tuning gang, for the other chassis, I'd be really interested to perhaps purchase one. Hopefully this mechanism's not too difficult and I can recreate it. But yeah, the other chassis has only got the two centre knobs. The chassis itself looks reasonably complete, but these have been taken off and somebody has tried to restore it. And I suspect the other one, the console, came through a friend of mine who, knowing my love of Pacific sets, offered it to me, and I gladly accepted. And then, because he was in the North Island and I was just passing through and had barely any room in my vehicle, kind of sat scrunched up in the driver's seat. I'll see if I can find a photo of that. It's kind of hilarious just how little space I had left for the rest of that journey. Now, not screwed in from the bottom, that's right, these chassis are screwed in at the back. And as you can see, the chassis has been painted. You may not be able to see just how badly, but it looks like it's been brush painted with some modern gold paint. The original colour of this chassis would not have been that. So if you're in Australia or New Zealand, you'll possibly recognise this stuff. It comes from Super Cheap Auto. There's possibly other places to get it, but that's where I know. Not sure if that'll focus, but new copper is the colour. And I've used this on a Rolls chassis, and if you look somewhere on the screen, you'll see a picture of the Rolls chassis and the original colour and this sprayed on. It's a very close match, and without spending much money on matching colours, that was pretty close anyway. So, and I think it's going to be very, very close, probably the same kind of paint and colour as what this would have had. So that's what we're going to potentially use. The cabinet on this one, it's been done, but like I said, I think it's polyurethane. I'll do some tests with some lacquer thinner on it, and if the lacquer thinner takes it off, then obviously it's lacquer. If the lacquer thinner doesn't touch it, then it's probably polyurethane, which means I'll need to use a stripper on it. And I've got some stripper that's actually really good. And I've used a few different kinds. Sally's is a really common one. Never been totally impressed with the Sally's product though. For getting varnish off, I've had, or lacquer off, I've had mixed results with it. But this stuff is really good. So this is the stuff I use. And that's either from Mitre 10 or Bunnings, I can't remember which, but it's just magic stuff. Really happy with it. Works really well. Gets into corners, it takes stuff off. Really works well. But I am not sponsored by them. It's just product I've found that I'm really happy with. Okay, let's have a look. Get this cabinet out of the way. I'm pretty sure we also had a Vincent Precision Radio Limited stamp on the inside of the Rolex cabinet. So that's interesting. Now I wouldn't say they're a big company, but I see their labelling on a lot of sets from Christchurch. So they must have been fairly popular through the sort of 50s, 60s, 70s. I don't know anything about the company. It'd be interesting to find out some more. If you do know anything about Vincent Precision, let me know. But yeah, they're quite prolific. The stickers and badges I see on sets from the Christchurch area. If we take a look, we've got the mismatched height IF cans. Now that was sort of common 1934 super hits from Radio Corp to see one up, one down. 34 and early 35 sets had this mismatched can set as well. The paint has just been slapped on everywhere. I really hate seeing paint like that. We've got, and possibly see there, the dial. I'll try and get a better photo of it, but the dial's got Radio Corp NZ, 18th of the 5th, 1934, date in the corner. Tuning Gang's also got one dated, looks like October 1933. Given that this was the only chassis to use NSC, the fact that that was made halfway through 34, this set is probably from halfway through 34, unless that's been replaced. This serial number is serial number 115, so it's probably a fairly early set in 1934. So it's possible that these sets didn't actually come out till sort of mid-34, which is interesting. I will have a look at the advertising and just see what date that advert I showed in the last video that has pictures of this on it. Because typically I would have expected the production parts for these sets to have been a bit earlier than that. Oh wow, it's painted the valve sockets and everything. Yuck! I'm not going to continue to pull this set apart at this point because what I'd like to do is actually run it up. So let's have a look underneath. There's a bit everyone's just wondering why I'm taking so long to do. See some cork stuffed electrolytic capacitors in there. Now if they're original, that's the first time I've seen caps like that on a Radio Corp set. That's really weird. I don't know if they are original. I think they've been removed from the other chassis, so I don't have that to compare against. But I haven't seen those particular style on anything else. Now I'm going to need to be really careful here because I do not want these taking the weight. So what we've got is a set that's had extensive work done to it. Dubilier caps, 32 mic. That is certainly higher than they would have been originally. I think from memory these were 8 mic filter caps. at least they've used the tags of the original caps to mount tag strip and use that rather than just leaving the old caps in circuit. There is some old Dublier moulded resistors, which is really nice to see. Those are original. There's a mixture of green caps and orange drop style caps, and the bog standard sort of modern yellow poly caps. There's a mixture of what looks like metal film, carbon and metal resistors in there. It's had a lot of work done, and it looks like at different times. So there's nothing particularly original about the insides of this one. I don't recall from the other chassis what condition that's in terms of originality, but this has had much work done. So, given that it's had a lot of work done and that everything looks fine, it's reasonably solid, there's no obvious problems. You know, the mains wiring looks good, the insulation's still fairly supple. The transformer, now the transformers in early Radio Corp sets, the HT wiring is quite often rubber insulated and breaks off. Only the HT wiring typically on these transformers. I forget what they are, a T56 or whatever the part code is, I don't recall. Really common on these earlier sets. And you can actually see here, possibly see here, there's some yellow wiring just down in here. And that's it looks like the HT wiring. And that is not long for this earth, so that'll have to be fixed. So I actually think that we can run this up, and I suspect that it will work because the work that it's had done to it looks reasonably recent. I've got some 500 volt with a 560 volt peak. They're Nippon Chemicon, I think. These will do the job nicely, I think. So we'll get those in, I'll work out where I'm going to earth them, then we'll power it up again, check, see how things are looking. So for the moment I'm going to do the ugly job. I'll come back and tidy this up later. Light bulb switched off. And contact. Alright, that's dimming out much better. It's still bright, but it is a 7 valve set, so it will be pulling more current than your average 5 valve set would, so it should be a little bit brighter than normal. Well, that actually sounds pretty darn good. That one not so much.
He was feeling.
It was a combination of both. I mean, Jim's a very fair-minded person.
So I'm just using myself as an aerial. I'll wire it up to, I've got a wee bit of a long line just hanging out the window here.
a.m. on that day was just a fair response.
So we've got a wee bit of electrical noise in the background. So the interesting thing now will be to see if I can get the NSC to do anything and see if that makes any difference.
That really, on that day, that took its toll, plus the element of
Alright, so I can't hear any difference at all there. Tone control's working. And the tone control is definitely the on-off switch. Volume's working, it's loud, it's reasonably clean sounding. So the set is actually fully operational. I'm not overly enamoured with the way it's done. Obviously there's a few things to sort out in there, but there's not going to be a whole lot to do to this chassis. So I think in the interests of making it interesting, what I'm going to try and do is get the other chassis going as well. The NSC doesn't seem to be doing anything, as I said, but the mechanism is pretty well knackered. I will zoom in for a closer look at the mechanism. Crow dial mechanism from the US. If anyone has any, looks like I might need about 3 of them, because this one, unless I can repair it, is not doing anything. The mechanism itself is pretty jammed up, and I think that wire wound resistor in the back is not well either. If I manually turn it, it is working. So whatever acts as a friction agent between this shaft and this strip of metal down here is just not working. But manually turning it didn't seem to be making any difference, so we will check that pot, check the condition of it, check the value, make sure it is doing what it is supposed to be doing. It is a wire wound pot. That's going to be a little bit hard to show, I think. If I turn the overall mechanism, it is actuating it, but whether or not it's actually working, I don't know. Whether or not it needs to be a wire wound pot, or that was what they had back in the day, we'll take a look at that as well. It's possible we can get away with a standard pot, but it may also burn out a standard pot if there's excessive current going through it. So the other thing we'll need to take a look at is the dirty dials. I have a number of ways that I can try and clean this dial up, because as you can see it's quite a bit of muck on it. It should all be this nice sort of tanny colour. You need to be really careful because the ink may be water soluble. It's my experience with these particular dials that it's typically not, and actually they're reasonably robust. The thing that takes them off the most, or causes the most damage, seems to be these pointers just getting pushed in against it, and then the constant action back and forth will just rub the ink off. But on this particular dial there's a cut mark that's been screen printed on there along the top, presumably to allow the young schoolboy or whoever they made cut these out, give them something to follow. And so I'll try cleaning up here in this corner, and if it takes off the dirt, that's great. If it takes off the ink, that's not so great, but at least we haven't damaged the dial itself. Now it is moving the dirt slowly, but slowly is definitely the term. It doesn't actually, it doesn't even look like it's really moving that much dirt. So that's going to take some cleaning. I'll do that. I'll find out what material is going to work best, or what fluid is going to work best to take that off without damaging it. It's got some writing which I hadn't seen before, and it looks like this end it says silent tuning, and at the other end it says full sensitivity. So I wonder if the noise suppression control was something that you turned down while you were tuning in and then turned back up again to a point where the noise was bearable. Be interesting to get it working and going properly, but what we'll do now is jump over to the office and take a look at the schematic and how this actually is wired into the circuit, because it's quite interesting and I don't fully understand it, but we'll see if we can figure it out. So what we've got here is the schematic for the Model 107, and we can tell it's the 107 not because it's written on it anywhere, but because it is the only model that has NSC, or noise suppression control, and here's our noise suppression control here. So it's dated from sort of mid-1934. Quite often the schematics would come out after the sets. That's a reasonably common thing to see. They would have lab drawings, and if you have a look at some of the Radio Corp sets, and I'll see if I can link one in just to show you what I mean, there would be a lab version of the drawing that was obviously drawn up by the engineers. The set would have been built, tested, extensively tested, and modified from there, and then the sets would be delivered and the schematics would be sent out to workshops all around the country. You know, these schematics probably would have been available to service shops that asked for it, and there was probably a fee involved. I have never found any information as to what the procedural cost was, and I'd be really interested to hear if anyone knows, or whether they just provided them gratis to people who are working on their sets. Alright, so looking at this schematic, what can we see? Well, the first stage here is a 58, and that is the RF stage of the set. So it's kind of like a pre-selector, pre-amplifier. So the RF stage works something like this. We have a coil, and I'm just really simplifying the circuit down here, and we have a tuning capacitor. They're in parallel, forming a tank circuit, which in turn is going to feed its output into the grid of our 58 valve, and that means that that signal will then be amplified before passing on to the next stage. So that's the two purposes of the RF stage, or the first stage of this radio. This one pre-selects a frequency and discards everything else, so it acts as a band pass filter, and then whatever is accepted from that band pass filter is then amplified and passed on to the next stage. So that band pass filter works something along the lines of, if you imagine that this is the RF spectrum, and we'll say that, just for argument's sake, this is the AM band or the broadcast band in here, and there's going to be a level of RF energy, and it's all coming in here. It's all coming in via the aerial through this coil, which is inductively coupled to this one, down to ground, and then this is selecting part of that based on where this tuning capacitor is fixed. So let's just say it's fixed at 1000 kilohertz. So that's the frequency, or the resonant frequency of this tank circuit. Then what happens is it just rolls off the frequencies either side. So these get rejected, and at a certain point you consider that there is not enough power to matter. So there's actually a band of frequencies here which is passed on. So it's not just that 1000, it might be say 950 up to 1050, which is passed through to the next stage. So then the 2A7 comes into play. Now this is a really common arrangement so far, 58, 2A7. 2A7 is a mixer. We've got our oscillator coil down here. This is the third gang on the tuning condenser. And once we have mixed our oscillator frequency with the incoming signal, we get a bunch of resultant frequencies, one of which should be the intermediate frequency. And in this set, that is supposedly 175 kilohertz, although we'll play with that and just have a look. Fortunately, I've got two different chassis to check this on. The 175 kilohertz was scrawled on the schematic. I haven't found it written down anywhere yet. So it's going to be interesting to see what the two chassis we have are, and whether or not 175 is actually correct. So that 175 kilohertz is now a fixed frequency containing our audio signal that we're trying to listen to. The IF is tuned on either side of this inductive coupling to refine that frequency down and further reject anything else. It's then typically amplified by an IF amplifier. In this case, it's being done by a 2B7. You wouldn't normally expect to see the 2B7 here. You'd expect to see it way over here where this 57 is. The 2B7 is typically used as a first audio and detector, and this is where it normally lives in the circuit. It's being used in a reflexing mode. Okay, so I filmed this walkthrough of the circuit a few days ago, and I thought I understood what was going on. Turns out I'm not quite as smart as I didn't realize I wasn't. Now that I've gone back and looked at it and spoken to a couple of people and looked at it some more, it's just not reflexing. All right. So what you would expect to see here if it was reflexing is the audio being pulled out and fed back into this half of the first IF transformer and being fed back in to be amplified. So in a reflexing receiver, the IF valve would amplify the IF signal, feed it back as audio, and amplify the audio signal as well. That's not what's happening in this case. The audio is being pulled out as per perfectly normal and passed on to the next stage. Hopefully I'm not steering you too far wrong, and if I am, I'm sure someone will point it out down below. But here's what I think is happening. We have the IF signal with the audio on it coming in, being amplified. It is then coupled through the second IF transformer at 175 kilocycles, remember, which we think is the IF on this set. And it can go this way, or it can go back in here. Now, any IF signal that goes this way will be dumped to ground by this 100 pic cap and this 500k resistor. Right, this pi filter here, there's two 100 pic caps. In the set, I actually had a look, there's only one, this one's not here. But this is really all it needs because there's a 0.1 mic cap here which will do the same thing to the IF signal. So the only way the IF signal is able to go is back here, and then on this diode it is detected and the audio is taken out. So we've got audio in the circuit as well. The audio can pass through here, and the audio passes through and then is basically fed through the volume control and on to the first audio. This here is the NSC part of the radio. This is the bit I still don't fully understand, but once we get the set working with NSC working, we should be able to actually have a look at it and see what's going on. Now, my best guess was that this 0.01 was dumping all of the, or the bulk of the audio out of the signal, and this 0.1 on the plate is kind of like double duty doing the same thing. So whatever comes out of here is going to be very low frequency, possibly even DC. And the amount or the amplification of this is being controlled, I believe, by the screen grid, which is the NSC variable resistor that sits up on top of the chassis. So this line here is the screen grid power supply, which is probably going to be 90 to 100 volts. So it's going to be anywhere between 0 and 100 volts, or whatever the screen voltage is being fed onto the screen grid here. That is being passed on to the suppressor grid and the cathode of this 57. So best guess is it's controlling, because this will be inverting the signal, it'll be controlling the audio as some kind of noise cancelling, and from talking to other people, that's the take that they had as well, some kind of squelch control or noise suppression. Well, obviously noise suppression, that's what it's called, but exactly how it works we won't know until we get it working. Well, I won't know till we get it working, and that's basically what I'm going to do, is make it work so I can see what effect this valve has on this one, and we'll scope a few pins and just see if we can see what's happening to the signal, because I think that's going to be really interesting. And then from there, it's fairly straightforward. You're going to see this in pretty much any radio. the amplified audio signal coming out through this 0.01 and into the grid of the 2A5, which is our power valve, and that is going to develop the audio signal across these two pins, which the speaker plugs into. That's the output, the transformer of the speaker, which you can see down here. So those two pins across the transformer and then out to the speaker itself. These two are the field coil for the power supply. So that's it. That's all there is to it. Simple, huh? Yeah, okay. Right, back to the garage. Okay, so I'm not sure how much of the previous footage I took that I'm actually going to use, because I've just realized that actually what seems like a better camera is probably a worse camera, and I'm not sure how well it's focusing, but even if it's focusing, it's really hard because it's so big to get in close. So apologies for the shaky hand camera job here, but hopefully you can see this just below my finger is a resistor and a capacitor. That shouldn't be there. That's the cathode. And that is a cathode bypass cap, and that is cathode biasing that resistor. So, according to our circuit, the cathode should be earthed, and this set uses back biasing. You can see here a resistor divider setting up back biasing. So that back biasing basically means that the grids are more negative than the cathode, which they need to be. If I can find it, I'll link in a great video that David Tipton did recently where he actually went through the whole amplification of audio. There's another really good explanation or two done by Uncle Doug, who does videos on guitar or valve guitar amplifiers, and he has a series of videos where he explains different things about power supplies and biasing, cathode biasing and back biasing. It's quite good. So those videos exist. There's no point in me trying to confuse you even further. So you can see here down in here, cathode and resistor, so that one has been cathode biased as well. This one maybe not. And in fact, it actually looks like, well, look at this one. There are some empty pins that didn't used to be. Now that will be, this one is the noise suppression control. Noise suppression control has been completely eliminated from this set. So if that's the case, me thinking that this was a good working set and that most of the time would be spent on the other one, well, that's just gone out the window, because whilst this is a good working set, it's not even close to what the original engineers designed this to do. And that means I'm not going to get to see what the original engineers designed it to do, and that does not please me. So that's good. That gives us something to work to, and at this stage my intention is to document how it is now, because it's working, and then tear it apart. We'll strip the chassis down, because I want to strip this, well, not this paint, but this horrible hatchet job on the outside that's been brushed on with some toy gold paint. And then I think we're going to rebuild this circuit as well as we can, and I may even try and do it as vintage as I can. So we'll find some Radio Corp capacitors, because they did make their own. I don't actually know that they were making them in 1934, but by 1935-36 they were certainly making their own capacitors in the factory in Courtney Place. So I have a few of those in my bin of capacitors that I've pulled, so we might restuff some capacitors. I've got a box of old dog bone and old other types of resistors. We'll see if we can find some of the right values, and we just may go through and put this back as near as done as we can to what it should be. So that's good. That's given me purpose and direction, and somewhere to go with this. So watch this space. That's the plan.